I'm hoping to keep this to about sort of 20-25 minutes or so. And in that time, what I'm hoping to do is give you some information about the School of Chemistry here at Cardiff University and the different degree programmes that we run here, and give you a little bit of information about the overall kind of application process in terms of things like entry grades and so on. Okay, so first off, I guess the good question to ask is, what is chemistry and what does that mean to you as a subject? So at the moment, those of you that are studying it in school or maybe colleges at the moment, you probably think of chemistry in the very broad sense of inorganic, organic and physical chemistry, because that's typically how it's taught at school level. And they're really nice, neat little boxes into which we can sort of package chemistry up. But when you come to degree level chemistry, you'll realise that as a subject, chemistry is so much broader than that. And we're really tackling a large number of grand challenges within the chemical sciences here at the Cardiff University. And we cover those grand challenges within our degree programmes as well. So we focus on topics like net zero and climate change, trying to tackle kind of clean water and reducing air pollution. So that's very much focused towards catalysis. But then we also have a lot of work that's being done on medicinal chemistry, so things like enzymes and protein folding and so on. And then using computational chemistry to be able to kind of study those physiological processes. And then also we have research here in the department and also undergraduate topics covering things like new materials, so advanced materials, things like battery technology that we can use in our mobile phones, things like OLEDs that we can have in television screens and so on. So really chemistry as a discipline is incredibly broad. And you will get to understand all of that in much more detail if you studied a degree in chemistry. So just want to touch now a little bit on the different degree schemes that we run here at Cardiff. There's a couple of different programmes and I'll talk a bit about each of those in turn. So to begin with, you may be aware that we have two general programmes in general chemistry. So that's the BSc programme and then the MChem programme. And you can see here the entry grades for these two schemes listed on the screen here. And just for information, all of the updated information about entry grades is posted on the university website. So please do go to the website for all of the up-to-date information on entry grades and tariff points, because it will also list there things like alternative qualifications beyond just the standard A levels. So again, to just summarise then, for the bachelor's programme, this is a 3-year programme in chemistry. In this bachelor's programme, there is the opportunity to take an optional placement in the 3rd year of the degree programme. So our students can apply then to do a year out. So during that year out, the students can go and either work in placement or they can go and study abroad for that 1 year. And then they return to Cardiff to do their final year of their BSc programme. If the students take that optional placement, that 3-year programme becomes 1 extra year in duration. So it's a 3+1 degree. So the overall duration would be 4-year programme for that if the students take that industrial placement option. If they choose not to take that, then it's just a standard 3-year programme. The MChem programme, so that's a Masters in Chemistry, is an integrated Masters programme. And this again is 4 years in duration. So we have years 1 and 2 in Cardiff, year 3 and year 4. Again, there's the option in the MChem programme to do a year abroad or a year in industry. And again, this takes place in year 3 of the programme. If students take this option on the MChem degree, this optional placement does not add an extra year to the programme. So the integrated masters is always 4 years in duration, irrespective of whether or not the students do that optional placement. Those students that take the optional placement have to undergo distance learning. So the core modules that are delivered in year 3 of the programme, the students need to take those via distance learning during that optional placement year. So it does require a bit of time management on behalf of the students because they need to do that distance learning alongside their paid placement job. So these are the 2 general chemistry schemes that we offer, the 3-year BSc or the 4-year Masters programme, Masters in Chemistry. Alongside that, we are also offering a different degree programme in medicinal chemistry. So this is a BSc in medicinal chemistry. And again, the entry grades are listed here on the screen. This is a BSc programme, so it's 3 years in duration. Again, there is the opportunity for students to take that optional placement year to do a year in industry or a year abroad as part of that degree programme. So I'll now just focus a little bit on the overall content between those schemes and how the medicinal chemistry programme is slightly different to the general chemistry BSc and MChem degrees. Oh, it's just worth noting before I do that, the first year of all of these degree schemes is the same in terms of content. So it's completely possible to transfer between any of these 3 degree schemes up until the end of year 1 of your degree programme. At that point, things are slightly different then between the BSc and MChem versus the medicinal chemistry programme. So between the BSc and the MChem, it's actually possible to transfer between these programmes right up until the end of year 2 of the degree programme. However, the medicinal chemistry stream becomes quite different in year 2 of the programme, so the only point of transfer here for the medicinal chemistry stream is after year 1 of the degree scheme. So if at this point you're really not sure which degree programme it is that you might want to study, just to let you know there's a degree of flexibility in that, and you can actually change your mind even after your enrolment. And we would advise all of our students to chat with their personal tutor to decide on the best degree programme for them during their time here at Cardiff. Okay, so again, in a little bit of detail, what is the content delivered on these programmes? So for the BSc and the MChem programme, in year 1, most of the content in year 1 is core, which means that we tell you what you need to study in that foundational year. There is, however, one optional module from which the students can choose, and at the moment our optional modules for our year 1 modules are environmental chemistry, green and sustainable chemistry, and drug development. Now, please note that this drug development module is a core requirement for those students studying the medicinal chemistry programme. So on the medicinal chemistry programme, there are no optional modules in year 1. All of the content is core. In year 2 of the degree schemes of the BSc and the MChem, again, all of the material in year 2 is core material. So again, we tell you what the curriculum is for that year. The reason that we deliver the programme in this way is because we're using years 1 and years 2 to give you the building blocks of knowledge that you need to study chemistry as a degree discipline. So we're really giving you the fundamental learning building blocks of chemistry as a broad subject here. And then as you go into the latter parts of the degree programme, that's where our students are able to start selecting their range of optional modules to cater their degree programme to their own particular areas of interest. So in years 3 and years 4, there are a range of optional modules that contribute sort of upwards of 50% of that year. And the range of optional modules that we have available at the moment on our programme are again listed on the screen here. So you can see that they're very broad ranging. So we have optional modules in homogeneous and heterogeneous catalysis, green chemistry, so again, that's a sustainability and things like net zero. Bioinorganic chemistry and bioimaging. So again, I mentioned that we have a lot of research here in the department that's focused on biological chemistry, and this is embedded within these optional modules here as well. We then have a range of modules in organic chemistry and inorganic coordination chemistry. And then also some modules in the more materials aspects of chemistry. So spectroscopy in terms of analysis, advanced materials, and then also recognizing that computational chemistry is also incredibly important and is really growing in the field of chemistry research. We also offer a range of optional modules there using computational chemistry and molecular modeling. So that's the general BSc and MChem programme. So now let's focus a little bit on the medicinal chemistry programme, which differs slightly from those 2 general chemistry streams. So again, in year 1, as I mentioned, the year 1 content is exactly the same as the general chemistry streams. So that will be covering topics of inorganic, organic, and physical chemistry. And then in year 2 of the program, this is where the medicinal chemistry program is slightly different, and it really focuses more on sort of pharmaceutical type chemistry. So the BSc medicinal chemistry program is really designed for students that have an interest in organic chemistry, pharmaceutical chemistry, but maybe don't want to be a practicing clinician, so they maybe don't want to go and study medicine, so they don't want to be a doctor, but they still have an interest in how drugs are designed, how drugs are developed, and how then they're administered to patients as vaccines, for example. So in year 2 of the medicinal chemistry program, then we have a much more of a focus on organic and synthetic chemistry. So really thinking about how am I going to design a drug and how am I going to then get that into a patient? Topics on pharmacokinetics and pharmacodynamics, drug target synthesis. And then also we have a range of modules on project management and business skills. So this is really exposing students to the really broad overarching idea of how the pharmaceutical industry works in practice. So what things need to be considered throughout that whole design and implementation of a drug into clinical trials, and then, like I say, into being an active vaccine target. And then again in year 3, there's a real focus then on the synthetic and organic chemistry. Again, we have modules in computational methods, and also then some supporting modules on data handling and statistics. Again, recognizing that large-scale statistics is really important within the pharmaceutical industry. For that medicinal chemistry program, we have a dedicated laboratory space within the department, and within that laboratory, we can focus on small to large scale up of drug synthesis. Again, there's a range of industry approved spectroscopic methods and analytical methods, and our students are also utilizing e-notebooks as part of their laboratory sessions there as well. Okay, so I mentioned that for all of the degree programs that we run here, so the BSc, the MChem, and then the medicinal chemistry scheme, it's an option available for all of our students to take a year in industry or a year abroad. They're 2 slightly different programs. For the year in industry, our students undergo a competitive application to get a placement year with an industrial company. And our students in the past have worked at a very broad range of different companies, such as healthcare and pharma chemistry, agrochemistry, and then also some students have gone to work in sectors including like the finance industry, so using their statistical skills and mathematical skills to understand the financial sector. There is a fee reduction during that placement year, and you do get paid a salary by those companies, and they're pretty competitive salaries for these placement schemes at the moment. So that's the year in industry. They are a full 12-month placement. Again, you're employed as a member of staff by that company for that full 12 months. As an alternative to the year in industry, students can opt to do a year abroad. And that's where our students go and become effectively a member of a research group at a university in a foreign country. So they're not studying modules, they're not attending lectures at that university, but they're fully embedded within a research group. And during that year, they will work on a research project under the supervision of a member of academic staff, working alongside PhD students and postdoctoral scientists. And you can see from this world map on the top of the screen here that all of these little red dots that you can see on the screen, they are all places that our previous students have visited as part of their year abroad programs. So we really do have links with lots of universities across the globe, and they typically stem from our research connections. And so again, really our students do have an opportunity to go and visit some spectacular places for that year abroad placement. The university can offer some assistance in terms of travel costs, and it is worth noting that these year abroads are typically only 9 to 10 months in duration rather than the full 12 months. Okay, so I guess one thing to also think about is why you might want to study a degree in chemistry and where it might take you. So some of those on the call at the moment may have a pretty good idea what it is that they want to do after their graduation. Others may be less certain of that. And I think it's really worth noting that as much as chemistry is not a vocational degree, what it does is provide you with a really broad range of skills, a very broad knowledge base that is incredibly valuable to a wide range of employers. And here in Cardiff, we have a very good employment statistics. So within 15 months of graduating, 94% of our students are in graduate level employment. So that means that they have to have a degree in order to be able to do that job. But what types of jobs have our graduates gone into after studying here at Cardiff? Well, like I say, it's incredibly broad. So all of these company logos that we can see on the screen here are places that our students have been employed by after their degree here. So you have some pretty standard sort of chemical companies, so think places like Unilever, DuPont, Kingspan. They're very famous now for making insulating materials, and Pharmaron are obviously a big pharmaceutical company. Then you also have some more sort of analytical type companies. So Radley's and Katsai are analytical companies. And then we have the more unusual companies like the food and drink industry. So one of our past students was incredibly good at doing distillations in the laboratory. And since her graduation, she went to work for Glenmorangie, the whiskey company, and is now the head distiller at Glenmorangie. We also have sort of non-lab based employment prospects. So a lot of our students have gone to work for places like UKRI, which is one of our funding councils. Working for the patent office. So if somebody wants to file a new patent for a new piece of technology, then the patent office needs to have scientists and engineers to review that patent and understand the background science within it to make sure that actually, yes, it is a new and novel development. And then also, again, using our sort of their mathematical skills to go and work for places like the ONS, for example. Again, there'll be some students on the call that have an interest in more sort of biological chemistry and may be interested in that sort of part of the chemical disciplines, and then go to work in companies that are related to sort of medical and biological sciences. So working for companies like the NHS to do clinical scientist training, for example, and then Biotage as well as another medical company. And then again, some more slightly unusual examples are more engineering type companies, which you may not think would be suitable for somebody with a degree in chemistry. But companies like Airbus and Williams and Rolls-Royce, all of the big car manufacturers, are now also very interested in employing chemists within their workforce, especially now with the development towards battery vehicles. So one of our previous students is now working for Williams Racing for their E team rather than their F1 team. And he's working on developing more battery technology for the Williams Racing team there. So really, like I say, some quite unusual degree prospects available, studying chemistry as a degree discipline that you may not typically have associated with chemistry as a subject. Again, it's also worth noting that lots of people are very interested in how much money they might earn after studying for a degree. So the Royal Society of Chemistry has recently published a pay and reward document listing the kind of salaries that people with a chemistry degree can go on and achieve after they're graduating. And the median response was an average salary of about 50,000, but you can see down this table here that in a broad range of different industries, so petrochemicals, pharmaceuticals, agrochemicals, for example, then there really are some quite high salaries available to students with that degree in chemistry. So it is a very broad degree and it does open lots of opportunities in terms of your employment prospects after graduating. So what does a degree look like here in Cardiff? You may have come across terms such as research-led teaching. So what does that really mean in practice? Well, for us in Cardiff, it means that we really put a lot of focus on how our research can be embedded within our degree teaching. So all of the textbooks that you can see at the top of the screen here have been written by academic staff here at the School of Chemistry at Cardiff University. So we do research alongside our teaching, but that research then feeds into our teaching in the form of writing textbooks based around that really specialised knowledge. And then those students can refer to those textbooks through their undergraduate learning. Alongside that, we also embed research within our teaching in the form of our undergraduate projects. So all of our students on the BSc programme and the MChem programme, the general chemistry one, and then also the medicinal chemistry stream as well, will all undertake a research project in the final year of their degree programme. It either lasts for one semester or for the two academic semesters within their final year. And those research projects really span, again, the broad expertise that we have within the School of Chemistry. So we can offer projects in analytical chemistry, in catalysis, computational chemistry for those students that have decided maybe they don't want to be doing wet chemistry, but they still want to be able to understand chemical processes, so they can do all their chemistry in a computer. Biological sciences, materials chemistry, and also sustainable chemistry. So our undergraduate students will be assigned an academic supervisor from our list of academic staff, and they will work in those research laboratories, again, alongside PhD students and postdoctoral scientists, working on an area of research that is of current interest to us as members of academic staff, really utilising state-of-the-art facilities in those research facilities. And if the students do an incredibly good job in their final year project, and they discover something new, something completely novel that nobody else has ever determined before, then they can get their name published on an academic journal. So all of the names that you can see highlighted in yellow on the screen here are undergraduate students that have done a piece of work in their final year project that contributed towards a paper being published in the academic press. So that's really what we mean by research-led teaching. Our students are really being exposed to cutting-edge research of interest to us as academic staff. And if they do a really good job of it, then they get their efforts noted by having their name published forever in the academic journals. Okay, so alongside that research project, what does a typical day at university look like, and how does it differ to what you might be used to now in schools or colleges? So typically we would say that in years 1 and 2 of the degree programmes, our students will have around about 20 contact hours per week. And that's made up of a combination of lectures, where we may have, about 100, 150 or so students sat in a large lecture theatre. Practicing wet chemistry in the teaching laboratories. Again, chemistry is very much a practical subject, so it's important that you gain practical skills during your degree programme. So you will have time within the teaching laboratories to develop your wet chemistry skills. And then alongside that, we also have a range of tutorials and workshops where we have much smaller groups of students. So our tutorial groups typically are about 10 students in size, and each tutorial group will be assigned 3 different members of academic staff, broadly across those areas of organic, inorganic, and physical chemistry. And you'll have a tutorial every couple of weeks, more regularly than that throughout the semester, where you can really focus on asking the academic staff questions that you may not feel comfortable asking in that big lecture theatre environment, and then also learning from your peers in that smaller tutorial environment. We do advise that alongside those 20 contact hours that you also have to put in a bit of self-study. So university, you are required to do a bit of reading outside of the lecture theatre. So we would typically advise that for every contact hour, you should be putting in around about 1 additional hour of self-study. So that takes you up to around about a 30-hour week, 30 to 35-hour week. So you do have a lot more autonomy at university than you may currently have in school or college, but it does require you to have a good degree of time management. So you need to organise your time so that you can get that self-study in and the assessments in around the contact hours that we put within the timetable. We are monitoring our attendance at lectures, again, just to make sure that our students are keeping engaged with the programme. So at the start of every lecture now, we put a QR code up at the screen to capture who's attending the lectures. And we use that as well as part of our wellbeing control measures as well. So if we can see that a student isn't attending lectures, then we can just reach out to that student, touch base with them and find out if everything is okay with them. We do, however, recognise that there are reasons why students can't always attend lectures. So say, for example, you have an interview for an industrial placement. That's a very valid reason for not attending a lecture, but we don't want you to miss out on that content. So all of our lectures are captured and recorded, and those recordings are released to our students following that live session. So what you can see on the screen at the moment is an example of what that captured content looks like. Just going to lose my laser pointer for a second. You can see that we have a video of the lecture theatre itself. We use visualizers where we can write on visualizers here to capture kind of written material. And then all of the PowerPoint slides that are presented in the lecture theatre also get captured as well. And this is how the package looks of that recorded material. Within that, there's quite a range of different tools that also the students very much like. So one of the options here is this 1x speed option, where the students are able to watch the recording in fast forward. And then one of the options that you can see here is this search box here. So the students can write into this search bar here a particular word or phrase that might have been said during the course of that lecture, and then the recording will automatically search for that word or phrase and provide a list of hits down underneath here. So if there's something that a student missed during a lecture and they want to remind themselves of what the lecturer was saying at that time, they can search for that and then go immediately to that part of the recording. These recorded videos are made available to the students within 5 working days of the lecture taking place, and they're available to the students throughout the whole of their degree programme. So it's a really valuable resource to students throughout their learning process within the active semester, and then also we notice that it's very much utilised as a resource during revision period for examinations. Okay, so I'm conscious very much that those of you that are joining us online at the moment may not have had an opportunity to visit Cardiff before, so you may not have had an opportunity to come along to one of our open days. So one tool that we have available on our website is our 360 tour. So this is basically a virtual reality of the whole of the chemistry department. So please do go along to the Cardiff website and look for that 360 tour link, and you'll see that it takes you to a page that looks like this. And you can see that it has a range of different tabs along the bottom of the screen. And if you click on these different tabs, it will take you into those different environments within our chemistry department here at Cardiff. So if I very quickly just press play on this and just give you a taster for what that looks like, you can see this is the corridor along the main building. And you can see now if I click on one of the tabs down here, it's going to take me into one of the research laboratories, and you can swing the camera around and have a look around that research laboratory. So you can really get to see all of the different spaces that we have here within the School of Cardiff. There are also some broader tabs as well of the surrounding area, so Cardiff City and Cardiff Bay and Penarth. So if you haven't had an opportunity to visit Cardiff as a city in the past, then you can also have a look at the wider environment of the university. Okay, so I've covered a lot of information whilst we've been on this call now. Just to remind you that all of the information that I've discussed here is available on our website. So if there's anything that you've missed, any more information that you might need, please do go along to the School of Chemistry web pages. All of the information about the entry requirements, the range of optional modules are listed on those web pages. We also have a YouTube channel, so if you wanted to have a look at the YouTube channel, there are a couple of videos available there with interviews from students that have undertaken those year abroad and the year in industry options, so you can hear firsthand how those experiences have been a positive learning experience for our previous students. If you did have any questions following this session today, then please do get in touch. So there's a range of email addresses on the screen here. So that's my personal email address. And then there's a general chemistry admissions website and email address here as well. So if there's anything that comes to mind after this session, then please do get in touch via any of these methods on the screen here. So with that, I'll thank you very much for your attention. I will just have a quick look to see if there are any questions in the chat. So I'm just going to stop my screen sharing for the time being, just to see if there are any questions that have been asked in the chat. Okay, so it doesn't look like there's any questions in the Q&A. It also doesn't look like there are any questions in the webinar chat either, but I'll hang on the line for just a little bit of time. But again, thank you very much for coming along today. Please do get in touch if you do have any questions. But thank you very much for your time, and I hope to see some of you in Cardiff. If you have put an application in, then just to note that there will be a series of offer holder days taking place in the new year. So those of you that have put an application into Cardiff should be getting an email with more details on those offer holder days soon. So they would give you another opportunity to come and visit the School of Chemistry here at Cardiff. Again, thank you very much for your attention, folks. Bye-bye now.